Hello, in this video we're going to be talking about angles and radian measure. You may have heard previously that there's more than one way to measure an angle, and you should always use the degree symbol on your number if you're going to be measuring an angle in degrees. That's because the other way to measure angles is going to be with radians. Today we're going to learn how you can find the measure of an angle in radians. Okay, we're going to be drawing angles in standard position, finding coterminal angles, and using radian measure. Okay, so first, what is an angle in standard position? Well, an angle in standard position has an initial side and a terminal side. Okay, so if you want to draw an angle, say a 90-degree angle in standard position, you would always use the positive x-axis, right, as your initial side. And then you're going to measure however many degrees or radians you need. And if we want a 90-degree angle, our terminal side is going to be the positive y-axis, right? And that would be a 90-degree angle. Okay, if I wanted a 200-degree angle, I would start my initial side on the positive x-axis, just like always. I would go around, this is 180, so a little bit more than 180, and maybe here I would have a 200-degree angle with my terminal side here indicating how far away from, how many degrees away from the initial side I needed to measure. Okay, so let's draw angles with the given measure in standard position. Our first angle is going to be a 240-degree angle. I could break that up and say that that is 90 plus 90 plus 60. Okay, in which case I would start, like I always do, with my initial side on the positive x-axis. I would go around 90 plus another 90 plus another 60 degrees, so about 2/3 of that, and this is going to be a 240-degree angle. Now you'll notice I'm using the degree symbol, and I'm also writing down the measure of that angle on its terminal side. Okay, so let's do another one. Let's do this angle that is 500 degrees. Now, 500 degrees is more than 360. So that means I'm going to go around my circle once and then keep going. So I'm going to go around 360 degrees. If I subtract 500 minus 360, I can break the rest of that up. That's going to be 360 plus 140. Okay, 140 is a little bit more than 90. I could say that this is 360 plus 90 plus another 50 degrees, right? I should be putting degrees on all of these, actually. Practice what I preach, right? So 360 all the way around plus 90 degrees plus another 50 degrees. So we go all the way around plus 90 degrees plus a little bit more than half for another 50 degrees, and this is going to be a 500-degree angle. Okay, now this next one, you'll notice, has a negative sign on this. So this negative sign means that instead of going up from our initial side, we're going to go down from our initial side, right? Down from the initial side, okay? In other words, we're actually going clockwise this time. So negative 50 degrees, here's my initial side, positive x-axis, just like all the others. And then 50 degrees is a little bit more than 45, right? So that's going to be a negative 50-degree angle. And I'm going to actually draw the fact that I went down. For our next example, we want to find coterminal angles. We want to find one positive angle and one negative angle that are coterminal with each of these. Okay, so our first one, we have a negative 45-degree angle. If you remember, negative means I'm going down from my initial side. So I'm going down. 45 is half of 90. So that's a negative 45-degree angle. A coterminal positive angle, well, I could go from the initial side. Positive means go up and stop. Coterminal, co meaning sharing the same ending side, coterminal, right? So coterminal, I didn't go around an entire 360. So if I do 360 minus 45, I get 315 degrees. So that's a coterminal angle with my negative 45-degree angle. Okay, it's also asking for a negative angle. So if I go down, that's negative, go past the angle, keep going around, and stop when you get to that terminating side again. So coterminal, sharing the same terminating side. Okay, so I went negative 360, and I also went negative 45. So in total, I went negative 405 degrees. So that's another coterminal angle with that negative 45-degree angle. Okay, the next angle that we want to talk about is 395. Now you'll notice that 395 is more than 360. It's actually 360 plus 35 degrees. So that 35 degrees right there is already a positive angle that is coterminal. So really, if I had a 35-degree angle right here, if I go up and around, and then to that, that is 395 degrees. But if I only go from my initial side straight there and don't go all the way around first, then that's going to be a 35-degree angle. Okay, now if I want a negative angle that has the same terminating side, instead of going in the positive direction, going up from my initial side, I would go down from my initial side. So I would start at the same initial side, and I would go down and stop when I got to that terminating side, right? So I'm going down, I'm going negative. So I'm going to do 360, but I'm starting at 35 degrees minus 360. So that's going to be a negative 325-degree angle. All right, so we've talked about using radian measures, but we haven't actually defined them yet. Now we're going to define them. Okay, what is a radian? A radian is a way that you can measure an angle using the radius of the circle. Okay, if I call the radius of the circle 1, right, what I'm really going to do is take that radius and I'm going to use that radius to measure along my circle, right? Except you notice the radius is a straight line. It actually measures a little bit more than this. If I keep it straight, it looks like it measures a little bit more, right? Well, it doesn't measure more because I need to take this and actually bend it to go along here. It would take one of those, another one of those, another one of those, and if you're bending them right, which I'm not, because my lines don't bend, you'll notice that this doesn't quite come all the way down. I mean, it comes 1, 2, 3, and a little bit more. Now, there's a special number that we talk about that says 3 and a little bit more, and that number happens to be pi. So if we measure if we measure from here, from the initial side of our angle, all the way around to half of the circle, that's going to be 3 and a little bit more, and it's actually 3.14159. You get the idea. That number is pi. So halfway around the circle is pi. A full all the way around the circle is 2 pi. And 1 radian right here is 1. This radius right here, we use this radius right here, and we line it up right here. If we could bend that, that angle would be 1 radian long because it's 1 radius bent along the outside of the circle. Okay, so a core concept that you need to understand is how to convert between degrees and radians. In order to convert from degrees into radian, you take your degrees and multiply it by pi radians over 180 degrees. Okay, and you'll notice that what happens is that your degree symbol and your degree symbol cancels out, and you can do a lot of reducing of this fraction. If you want to convert from radians into degrees, you take your radian measure and multiply it by 180 degrees over radians, and whatever your units were, your radians cancel out, and now you're converting it into degrees. So let's give that a go. We want to convert 120 degrees into radians. Okay, so we're going to take 120 degrees and multiply it by pi over 180 degrees. And the reason that we're using this fraction is because this fraction is actually equal to 1. Pi is halfway around a circle, and 180 degrees is halfway around a circle. So that equals 1. So 120 degrees times pi over 180 degrees. The degree symbols cancel out. I can reduce my fraction by 10. 12 over 18, I can also reduce those. If I divide 12 by 6 and I divide 18 by 6, we find that this is 2 pi over 3. Okay, the second problem here, we want to convert this radians. Now, the reason that I know that this is radians is because there is no degree symbol. Okay, so it's important to write the degree symbols so that you and your reader knows you're measuring in degrees. Because if you don't write the degree symbol, it means that you are measuring in radians. So we have negative, means we're going down from our initial side, pi over 12. I want to multiply that by 180 degrees over pi. Okay, now you'll notice here, pi cancels out pi, the numerator and the denominator. Okay, we can reduce both the numerator and the denominator by 12. So divide that by 12. And we find out that this fraction actually equals negative, remember, because we were talking about a negative angle, 15 degrees. Write the degree symbol because that's the unit that we're using. Okay, now it would actually be easier to not have to constantly multiply by either pi over 180 degrees or 180 degrees over pi. So we have what is called a unit circle. And the first part of our unit circle that we need to memorize is all the way around our circle, measure everything in degrees, and then the same exact angles that you've got marked in degrees, go ahead and mark them in radians also. So for example, if we had this angle with an initial side on the positive x-axis and a terminating side at 120 degrees, we could just know that 120 degrees is the same as 2 pi over 3. Okay, instead of having to calculate it, we could have our unit circle memorized. Okay, instead of having to calculate the fact that negative, so we're going down from our initial side, negative pi over 12 is 15 degrees, we could just know in our unit circle that negative pi over 12 right here, we would have halfway between 0 and negative 30 is negative 15 degrees. Okay, I would encourage you to pause this video and copy down that unit circle. Here, let me clear the ink, pause the video, copy down that unit circle. All right, now, what is super handy about measuring angles in radians is that your formulas for arc length and area of a sector become simpler, okay? So the arc length S is this right here. That's your arc length. And then the area of the sector is this shaded here in blue. Okay, the arc length S, you need to take the radius of your circle, R, times pi if it's measured in radian, or times theta if it's measured in radians. Okay, to find the area of your circle, you do 1/2 the radius squared times theta as measured in radians. Okay, so let's use this example. A softball field forms a sector with the dimensions shown. Find the length of the outfield fence and the area of the field. So the length of the outfield fence is the same as the length of this arc right here. So we're going to use our arc length formula. S equals simply the length of the radius times our angle measured in radians. Our angle right here is measured in not radians, degrees. So we know that 90 degrees is going to be the same as pi over 2. So we simply take our radius, which is 200 feet, and multiply that by our angle in radians, which is pi over 2. And I can reduce my fraction. 2 goes into 200 100 times, and I find out that the length of fence that I need is 100 pi. Since pi is 3.14, that is going to be about 314 feet. Okay, now to find the area of this, the area of the field, I need to do area equals 1/2 the radius squared times my angle as measured in radians. Okay, so I'm going to do 1/2 times 200 squared times my angle as measured in radius is going to be pi over 2. Okay, if I simplify that just a bit, we've got that is 1/2 times 40,000 times pi over 2. 2 reduces that, and 2 reduces that even more. So this is going to be 10,000 pi, and that's feet squared. If I know that pi is 3.1415926, blah, 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 I could write this in units not using pi. Thank you for watching.